So we're going to look at solving this equation. Now what you might notice about this equation is that it has unknowns, an x in this case, on both sides, and it has numbers on both sides. We know it's an equation because there's an equal sign there. That's what an equation is. Okay, because I'm solving, I'm going to end up with x equals a number. So I'm going to want my x on one side and my number on another. At the moment I've got x's on both sides and numbers on both sides, which I don't want. Now, quite a useful way to imagine our next stage and what we're going to do is think, because this is an equation, we know that everything on this side and everything on this side are equal. They are worth the same in total, or if you're thinking of them in the real world, you could imagine an old-fashioned set of scales where they both weigh the same, and in this case you've got 3x, so that's 3x plus 7 on one side, and 2x and minus 3, so let's zoom in a bit for that. Minus 3 would look 1, 2, 3, like that. Okay, if we're using algebra tiles, that's what it would look like. And this we've got 3x plus 7 weighs the same as 2x minus 3. But I want it to eventually look like a scale that on one side would just have x, and on the other side would have some amount of tiles for me to see they're the same. So as you can see on the left at the moment, I've got quite a lot in this scale that I don't want. Okay. For us to be able to do that, first of all, let's look at our x's on both sides. And I can see that I've got 3 on one side and 2 on the other side, so I could actually think which is the smaller amount of x's. Well, 2 is the smaller amount of x's. Let's get rid of that smaller amount of x's. And to get rid of 2x, you can take away 2x from both sides. Okay? Remembering that if I'm going to take away 2x from this side, I can't just take away 2x from that side, because then I would have this, which is then saying, which would then no longer weigh the same, it would be a different weight. So I have to make sure I do the same to both sides, which would look like this on that algebra. Take away 2x, take away 2x from both sides. And as you can see from the diagram here, 3x, take away 2x, I'm left with x. I haven't done anything to my plus 7. My 2x take away 2x, well those two cancel each other. 2x take away 2x is 0x, which is 0, take away 3. Okay, and that's what I've got in my diagram. So I've got my x by itself, that's what I want, in the sense of I've just got x on one side, but I've still got numbers on both sides, which I don't want. So I need to get rid of those 7, so I need to take away 7. But I can't just take away 7 from this side of the diagram. I'm also going to have to take away 7 from this side of the diagram, which I could do by adding 7 white squares, 7 inverse squares. So your diagram would now look like this, and in algebra, on this side, x remains here, plus 7 take away 7, well 7 take away 7 is 0, so that's just 0, equals negative 3 take away 7. Now before you go thinking some random answer that might be, have a look at the diagram. Hopefully you can see your negative 3 and your negative 7, which is the same as negative 3 take away 7, which is clearly 10 white squares, or negative 10. You could also use a number line to help you with that. So you'd have negative 10 here. So overall as our answer, we've already got written out nicely for us here that x equals negative 10. And I've solved it now. And of course, if I wanted to check it, I would put negative 10 back into my original equations. Let's try that. My original equation was 3x plus 7 is equal to 2x. Take away 3. If x was negative 10, 3x would be negative 30 plus 7 this side. This side I'd have negative 20, take away 3. Negative 30 plus 7 So 7 bigger would be negative 23, and negative 20 take away 3 is negative 23, and it is true that negative 23 equals negative 23, so I know I've got the right answer. Alright, we're going to have another example now. Let's see if we can figure out how to do this a little bit quicker. So again, because we're solving, we know we're going to end up with x equals, and if I had my scales again, I've got 6x, take away 5, this side, and this side I've got 3x plus 7. Alright, okay, and that's my scale, so I know they're equal to each other. So I look at which has a smaller amount of x's, while the scale on the right, the expression on the right has a smaller amount of x's here than this. There's 3 x's here and 6 here, so I can take away these 3. Remembering I must do the same. Oh, I've actually done 5 there. There, that's 6. I can take away 3 from both sides, so I write that on here. Take away 3x, take away 3x. Now please make sure that when you're taking away your x's, you're writing it underneath your x's, okay? You know, so I'm not writing it there. That's no good to me, because that's underneath my number. I want it underneath my x's. Each time I could draw a box around it. Okay, so if I took away 3 x's from both sides, it would look like that. And I'd be left with 6x minus 3x is 3x. Haven't done anything to the minus 5. 3x take away 3x is 0. That was the whole point. Plus 7, which is just 7. Okay, good, that's looking better. Now I don't want this minus 5 here. I want to put it onto this side. I want to get rid of this minus 5. Well, to get rid of minus 5, remember you'd need to have 5 normal squares, and then each pairs off to make 0, 2, 3, 4, 5. So those will disappear, but if I'm adding 5 onto that side, I have to add 5 onto that side. So plus 5, because the inverse of take away 5 is add 5, plus 5. Remember in box again, so we can see clearly. I haven't done anything to my 3x, that's still there, 3x. Negative 5 plus 5 is 0, just like that was 0. And I've got equals 12. I haven't quite finished, because I know that 3 lots of x is equal to 12. I also want 1 lot of x, so to get from 3x to x, I need to divide by 3. And so I need to divide 12 by 3. Well, 12 divided by 3 is 4. So I've got the x equals 4. And once again, I should be able to substitute that back in to check. So your first stage each time is you find the smaller coefficient of x, a small number of x's. In this case, out of 6 and 3, 3 is smaller. So do the inverse of 3x, which is to take away 3x, but I must do it to both sides so that my scales balance. After I've done that, my next stage is to do the same with the numbers, but in this case, it doesn't matter which number is bigger or smaller, it's about getting rid of the number that's next to the x. So opposite of negative 5 is adding 5, both sides, and then you've got something x equals something. You want it just to make x, so you just divide it by your coefficient of x in this case.